Hello everybody! So in this video and in the following videos I will show you some of the functionality of numpy or at least the functionality that we are going to use, the main functionality that we are going to use in this course and in the following course. So first of all, numpy. Numpy means comes from numerical Python, and it's a numerical library for Python, and it's very widely used and very important for all that has to do with numerical computation in Python. The main thing that we should know about the numpy library is that it mainly uses arrays, okay? So a numpy array is going to be an object that allows to storage and manage data, as long as all these data are of the same type, okay? This data, the type of this data is usually numeric, but it also can handle strings and other types. Okay, these things over here, we are going to see them in the examples, okay? And now we are going to see several ways to generate arrays. We will start right now. Okay, so first of all, the numpy library is usually imported in this way, okay, with this alias. We could import this library only using numpy, but then we should use, instead of np, we should write numpy each time. And okay, believe me, this is too tiresome. So it's much better to use an alias, and the standard alias for this library is npy. So once we have imported this library with this alias, now we are going to see a few examples of how to generate arrays, okay? So the first example is going to be from a list, okay? To generate an array from a list is very simple. We only need to write the data inside a list, okay? And then create an instance of an array using this list, okay? An instance is called is when we call a class, okay? This is the class that is going to be used to create new objects of this type, okay? So the point is that this is the class, okay? And then between round brackets, okay, parentheses, we are going to inside these brackets we are going to input the list, okay? This is the list that is going to make the new array, okay? And the elements of the array are going to be exactly the same elements of the list. So let's see what happens when we execute this. Okay, so when we execute this, what I obtain here, I'm just looking at this first part, okay, this part over here. I'm printing x, okay, so x equal array 1 minus 5 minus 2 1. Notice that this is these are the same elements as in the list. Then when we compute x dot size, okay, size is an attribute of the object x. When I say object, is the same as variable, okay, but variable is used for objects and for constants like 3 or a number or a string, okay, which are constants, but objects are used for classes. So when I say that I have an object, is because I have something a little bit more complicated than just a single number or a single string, okay? So in this case, as I was saying, I have that if I call x.size, okay, size is going to be an attribute of the object x or the variable x, okay, and the result is 4. And why is that? Because the number of elements that x has is 4. 1, 2, 3, 4 elements, so I have a size 4. When I type x.shape, okay, x.shape is going to give me the number of the dimensions of this array. Okay, so in this case, since the array has only one dimension, okay? We haven't defined more dimensions in this array. We will see briefly another example with two dimensions, okay? Well, then I have that the shape is going to be a tuple with only one element, which is 4, okay? And if I compute the length of x, okay, the length is computed by this function over here, okay, length x gives the length of any list or numpy arrays and other objects. So in this case I obtain also 4. Why is that? Because, well, the size is 4, but I only have one dimension, so the length is going to be the number of elements of this array, okay? And if we compute, if we print the type of this array, this is going to give numpy.ndArray. Okay, ndArray is an internal class that is used by NumPy. Okay, so we create new arrays using this function np.array. Okay, this function, no, this class, and the result is an internal NumPy array, which is an ndArray, and it's called ndArray because it's the generic of n-dimensional arrays. In the second example, I have created a two-dimensional NumPy array, okay, and this is called 2D array, and this is going to be created from a list of lists. So in this case over here, I had just one list with 4 elements, okay, 4 numeric elements, and in this case I have a list of lists. So the outer list has inside 3 lists, and all the lists inside the outer one are all of size or length 4. Okay, so I have the first list is of length 4, the second list is of length 4, and the third list also has length 4. So if I do exactly the same as in the previous array, but for the second array, okay, now the second array is going to be a little bit different. Now it's going to have this shape. Okay, so we see now that we have different rows and different columns. Okay, so it will have 3 rows, just as the number of lists that we have inside the outer list, okay, and 4 columns, which is exactly the number of elements that each list has. So that is how this array is formed, and this is also an array, and the type is also an ndArray. Okay, in the first case, this is a one-dimensional array, and in this case, this is a two-dimensional array. The size of this array now is going to be 12. Okay, and why is that? Well, because I have 12 elements stored in this array. Okay, and the shape is 3, 4, and why is that? Because I have 3 rows and 4 columns. And if we instead of rows and columns, NumPy talk about the axis. So the axis, the rows are going to be the first axis, which is axis 0, and the columns are going to be the second axis, which is axis 1. Okay, so we have 3 rows or 3 elements in the first axis and 4 elements in the second axis. Okay, and if we compute the length of this array, this is going to be 3. And why is that? Because 3 is the number of elements of the first dimension, okay, of the first axis. I hope you will find this more or less well. If you try more examples, I think that you will understand it a little bit better. Okay, so these are 2 very simple ways to create arrays, just using the array function, the array class, sorry, and using lists. Okay. Nice. Another thing, we can also create arrays from predefined functions. Okay, these are functions that are going to return a known array. So the first function that we're going to see is arrange. Okay, arrange is a function that is very similar. Well, yes, arrange is a function that is going to return a consecutive integer numbers from 0 to 10 minus 1. So if we, and this is why I've called these indices, okay? So because they are integer numbers. So indices, if I print these indices, this is going to be this array, okay? The result is the same. This is also an array, and this goes, the data in this array go from 0 to 9, remember this, to 10 minus 1, okay, in this case, and the shape is going to be 10 because I have 10, 10, a tuple with only one element, which is 10. So the length and the size are both going to be 10, okay, because I have 10 elements and I have only one dimension, okay, one axis, which by default is the 0 axis. Another way of generating arrays, well, is going to be, this was with the arrange function, but using with integers, okay, and now we are going to use the arrange function, but we are going to set a step, okay. So in this case, if we don't write any steps, then this is going to be, this is going to go from 0 to this number over here minus 1, okay. And if we write this with the steps, then we have to explicitly write the initial value, the final value which is excluded, and the steps, okay, the size of the step. So in this case, when I print linear 1 and I print linear 1 dot shape, then these are the results, okay. So I have that linear 1 now is not going to be just these elements over here, no, these are going to be 0, 0.5, 1, 1.5, 2, etc., until 9.5. And notice that 10 is not included, okay. So this is like, this goes from 0 to 10 on 0.5 steps until the last number is greater or equal than 10, okay. So so the last, that is why the last point is excluded, okay. And in this case, we have that the size is going to be 20. Well, if you count this, you can notice that this is going to be 20. Notice the difference between this array over here and this array over here. Well, the size is different, obviously, but also here we have we have no dots, okay. We have no dots here, and here we have dots. And why is that? Because this is an array of type of the type int, okay, and this is an array of the type float. In fact, I'm going to go to this file that you also have in your Moodle account, okay, of this course. So if I'm going to run this, so you can see we have exactly the same output as before, okay. And now we are going to, I'm going to run this. Remember that with this, if I select these 3 rows and I press F9, then it's going to run only these 3 rows, okay? Three lines of code. And well, what I have here is that I have created the indices variable, okay, which is an array. This is what happens when I print it, and this is the shape, okay. If I write len indices, this is going to give me 10, okay, because this is the shape of the first element, I mean the number of the first element here in shape. Since I only have one element, it's exactly the same, okay. I mean, it's well, these are always the same. And then what I wanted to do, yes, is to print the type, okay. So if I check the type of indices, well, this is a numpy ND array, okay. But if I want to know the type, okay, I think that if this works, I'm not so sure. The type, yes. And we see that these are int 64, which means that it's a long integer, okay. These integers allow for very large storage or very large integer numbers, okay. Okay, so this for indices, and if we repeat this operation with linear, okay, and we execute these 3 lines of code, what we have here is that, well, this is exactly what we saw before. Okay, now if I write length linear 1 is going to be also 20, okay, and if I print the type, the type of linear 1, okay, dot the type, then this is going to return float 64, which is a floating number with 64 bytes. Okay, so this means that this can store very large decimal numbers. Well, with a lot of precision, that's what it means. Okay, very large and very close to 0. Yes, another thing, and the last thing that I want you to show you is this function, which is linspace. Okay, if we execute linspace, this part over here, then what I have is that the linear array is almost the same as before. Notice that, well, linspace, what it does is to create equally spaced decimal numbers between 0 and 10, both included, and these are the number of elements that are going to be created, where the first element is 0 and the last element is 10. Okay, so since the last element is included, in this case, instead of 20, I'm going to create 21 elements. Okay, so we can have more or less the same behavior as before: 0, 0.5, 1, 1.5, etc. The shape is going to be 21 in this case, and if I had created linspace with only 20 elements, then the result is not going to be so nice. Okay, let's see what happens. Control C, Control V. Okay, this is going to be with 20 elements. Notice that the first element is 0, the last element is 10. Okay, but in between we cannot have 0. These are equally spaced numbers, okay, but the space is not 0.5 but 0.5263 blah blah blah. Okay, and this is because since we are using also the last element, then well, it's better to use in this case 21 instead of 20 elements, or 100 and if I want to create 101 elements, then these are going to be, you see, these are going to be just with a space of 0.1 between two consecutive elements of this array. Okay, and these all return arrays. Some other predefined array generators are come with the zeros function from numpy, ones function, diag or diag function, and empty function. Okay, so what numpy.zeros return is an array of zeros. Okay, and the shape is going to be given by this number over here. So if I write np zeros 3, 4, well, I'm going to execute all this cell by doing Control Enter. Okay, so I have here all these results. Okay, all these printing results. So I have that E0 is going to be an array, a two-dimensional array, because I have 3 rows and 4 columns. Okay, see, 3 rows and 4 columns, and all the elements are equal to 0, and this is why it is called zeros. Okay, so the shape, if I compute the shape, is 3, 4. Okay, 3, 4 is exactly the same shape that I've written here. If I do exactly the same with ones, well, ones works exactly the same as zeros, except that instead of returning an array of zeros, it returns an array of ones. So if in this case x1 is going to be an array of 5 elements, 1, 2, 3, 4, 5, and notice that in this case what I have here is, well, I have I have written this 5 over here, but if I do this in this way, the result is going to be exactly the same, okay? So notice here that I have this array and the shape is 5 comma, okay? Well, now let's see what happens. If I execute these 3 lines, I obtain the same array as before, okay? You can see that the array is exactly the same and the shape is exactly the same, because when I write here only a number and not a tuple, then this is going to be a one-dimensional array. So this is the same as writing this thing that I had before, okay? This is a tuple with only one element, okay, which is 5. The second element doesn't exist, okay, so this is a tuple with only one element, and this is the same as writing this, which is an integer 5. Obviously, since this has to be a size or a length or a shape, then what I have here, if I try to make ones of 2.3, then this is going to give me an error, okay, because a float object cannot be interpreted as an integer, okay, so in this case, this is the error that I have. Okay, other ways for defining arrays. Well, we can call the function diag. Okay, the function diag is going to return a diagonal to the array using the elements that I'm giving her to this function in the argument. Okay, so I have here a list or an array-like list of numbers, and okay, let's go here. And when I compute this thing over here and I print it, then what I obtain is this matrix or 2D array over here. Okay, so here we have that we have all the elements equal to 0 except for the diagonal elements, which are exactly the same as these 3 elements that I've written here in the arguments. Okay, and the shape in this case, this is going to be a square matrix. Okay, because the diagonal matrix is a square matrix. Another kind of array is going to be returned by the empty function. The empty function is going to give me an empty array, which means that it's not going to be empty, but the numbers, okay, the elements of this array are not going to be initialized. Initialized were all these arrays over here, okay? All these elements were zeros, were initialized by zeros. All the elements of x1 were initialized by 1s. All the elements of D were initialized by zeros if they were outside the diagonal, and the elements of the diagonal if they were, or these elements if they were in the diagonal, okay? But the empty array is not, this is not, the elements of an empty array are not defined, okay? This is garbage, basically, because it depends what it has in the memory at that moment, because it just is going to take at some place in the memory, okay, in the memory of your computer, is going to say, okay, I need to store an array of size 2, 3. And if I don't say anything, this is going to be a floating point number, a 64 floating point number. So this is going to be the elements that it is going to store. In this case, what we have are these elements over here, because in some previous execution, I had these things in memory. Okay, so that is why we have here. In fact, if I repeat this computation, okay, if I repeat this over here, probably the elements are not going to be the same. Okay, so I have this F9 now, and we have 0.519, 10. Yes, they are they are the same, but they don't have to be the same. Okay, in this case, it's the same, but it's not always that case. Okay. So yes, these are some of the functions that give well, predefined arrays. And we will see some other ways to create random arrays in the following video.